Okay, so in this video, I'm going to go ahead and show you how you can use implicit differentiation to find the second derivative of y. So if you look here, we know that we're taking the second derivative because of the 2's. We're going to begin by taking the first derivative of our function. So I'm going to go ahead and take the derivative with respect to x. So the derivative of x to the fourth with respect to x is going to be 4x cubed. The derivative of y to the fourth with respect to x is going to be 4y cubed. But again, because we're taking the derivative with respect to x, I add my dy dx. And the derivative of 16 is 0. So we have just found the first derivative, or we're on the way to find the first derivative. We first have to solve for our dy dx. So I'm going to begin by moving this 4x cubed over to the other side. And I get 4y cubed times dy dx is equal to negative 4x cubed. And then I can go ahead and divide both sides by 4y cubed. And so what I have just found is the first derivative dy dx. Now, as I'm looking at this, oops, I forgot my 4. I actually noticed that a 4 does cancel out, so I'm going to go ahead and cancel, simplifies to 1. So that's going to become negative x cubed divided by y cubed. And so this is my first derivative. To find the second derivative, I'm going to go ahead and differentiate the first derivative. Let me actually go ahead and rewrite this to show you this step. So what I have just found is the first derivative. To find the second derivative, I'm going to differentiate this equation. So I'm also going to take the derivative with respect to x. So the second derivative then is equal to find that, I'm going to have to use quotient rule, because I have a quotient. So quotient rule, let's see, the derivative of, low derivative of the numerator, the high. So the derivative of negative x cubed with respect to x is going to be negative 3x squared. Low d high minus, use those parentheses, negative 3x cubed. So low d high minus high d low, so the derivative of the denominator is going to be 3y squared. But remember, you're taking the derivative with respect to x, so times dy dx. All over, square the bottom, and away we go. So that's a 3 there. So let's go ahead and simplify this just a little bit further. The second derivative is going to be negative 3x squared y cubed. My subtracting that negative is going to become plus 3x cubed y squared times dy dx all over y cubed squared. So the way that we complete this process, you will notice that our second derivative has this dy dx, but we already determined what dy dx was up here. We already have the first derivative. So to complete the second derivative, you're going to have to substitute in for the first derivative. So dy dx gets substituted back into my expression. Making my way there. Boom. So now I get to go ahead and substitute in for dy dx negative x cubed divided by y cubed. All over, I don't know why I didn't simplify this in the last step, but y cubed squared is going to be y to the 6th. So at this point, you can see here that I have a y squared and a y cubed. So that is going, I can simplify out a y squared. So this is just going to become a y instead of y cubed. And the result is going to be negative 3x squared y cubed plus 3, well, let's go ahead and I'll go ahead and write this step. I'll rewrite it. I'll save that product. One more step. So now I can go ahead and multiply those two expressions, and I get negative 3x squared y cubed minus 3x to the 6th divided by y all over y to the 6th. So at this point, you could go ahead and stop because you have found the second derivative. However, you could also recognize that in the denominator here, this y to the 6th dividing by y to the 6th is the same thing as multiplying by 1 over y to the 6th. And so with that interpretation, we can now go ahead and distribute this fraction, and we get negative 3x cubed y cubed all over y to the 6th minus 3x to the 6th divided by y to the 7th. Ooh, goodness gracious, look at me go. Because now in our first term, you can see that we have a y cubed that can simplify out, leaving y cubed in the bottom, in the denominator. And so the result is going to be negative 3x cubed over y cubed minus 3x to the 6th over y to the 7th. And if you go ahead and just take a step back, I zoom out my work. Whoa! Yes, folks, it took an entire page to go ahead and take the second derivative. So remember, when you want to take the second derivative of an implicitly defined function, you start by first finding the first derivative. And then once you find the first derivative, you are going to go ahead and differentiate that first derivative. And then when it comes time, we're going to plug that first derivative back in. And basically, my steps are to simplify that expression as much as I can. Oops, simplify.